Hello viewers, this lecture is based on the chemical kinetics topic catalyst, but in this lecture we're going to talk about the processes or the classes of catalyst. As I told you in the previous lecture about the catalyst, its types and some common examples, and also I told that there are two classes, homo and hetero, in which the homo has again two species known as acid, base and auto. We're gonna discuss those species. Let me tell you the basic introduction of the catalyst. The catalyst is a substance that increases the rate of reaction or decreases the rate of reaction, but neither it is the part of the reactant, neither the product. The catalyst has two classes known as heterogeneous and homogeneous catalysis. Basically, hetero, the word defines itself. Hetero means different, and homo means the same. So basically, here the different and the same are referred to the phase of that substance. Phase means the state, whether a solution is in an aqueous solution, whether it is solid, whether it is gas, whether it is in the form of the liquid or the vapors. It depends on the state. So basically in the heterogeneous there are different phases of the catalyst and the reactant. Just suppose that a reaction now basically just have a look at this reaction. In this 2SO2 is reacted with the O2 in the presence of the catalyst V2O5 that produces 2SO3 plus V2O5, the catalyst, of course. Now here if you have a deep look at the reactants, so basically these two are in the form of the gas. The product is also in the form of the gas. But this V2O5 is basically a form of vanadium pentoxide in the form of a solid. So this is called heterogeneous catalysis. But if we have a look at the homogeneous catalysis, let me take a common example of homogeneous catalysis, and that is the catalysis of in which this is a example, a process in which CH3COOC2H5 reacts with H2O with the presence of the catalyst H2SO4, in which it produces a basic acetic acid plus C2H5OH. Now here if you have a look at the state of all these matters, so basically CH3COOC2H5 is a aqueous solution. H2O is basically a water aqueous solution. H2SO4 is a acid that is also an aqueous solution. Acetic acid is also a aqueous solution. After that, C2H5OH is also a aqueous solution. These all are having the same state. That's why these are termed as the homogeneous catalysis. Now let's have a look on the classes of homogeneous, and it has two classes. First one is acid base class and second one is autocatalysis. Let me first remove it. Okay, so basically in this case acid base catalysis, so at the initial the number of organic reactions proceeds categorically in the presence of H2O, and in that we do have H plus ions as well as the OH minus ions. In this reaction, it is a homogeneous reaction, right? So both of the states of the matter are the same. But here, the thing to be noted is that we do need a different catalyst of the same stage to react with it to increase the rate. This is a first phase. But in the autocatalysis, the product reacts as a catalyst. Like the product of that reaction basically works as a catalyst. Just suppose that we do have a water in which we're gonna dissolve some of the things like a iron. Just suppose that we do have a water in which we have already dissolved iron, and now iron is in the situation that it becomes aqueous. Now when we'll add another part of a solid iron, so what will happen? The product there also works as a catalyst. So basically the product that the iron will be melted up and become works as a catalyst. This is called a autocatalyst. The best example of autocatalysis is redox retardation between KMnO4 and oxalic acid, which is Mn positive ions. So basically, when this catalyst happens, the 2 moles of KMnO4 in the aqueous solution produces 2 moles of MnSO4. But here the product increases, and a product have water as well as carbon dioxide as a reaction. That's why it works as an autocatalyst. I hope now it is clear to you all, and thank you for watching.